Hey guys, I want to give you a rundown on my program, what kind of needs to be done next, and um, what all we kind of have to start doing as soon as we can. And a lot of this is because I'm going to be run extremely thin. So I tried to add as much documentation as I can and as much as I can onto the GitHub, right? So before we get into the code review, this is what we need to do as soon as possible, right? As I probably will not be in class tomorrow before 11, I would very much recommend all of you guys either look at this after class or look at this before class, or if you're looking at this after class, it's okay. But basically, what I need, and that is due to, unfortunately, I'm dealing with some medical problems right now. So here's the GitHub, right? And in this GitHub, we have a bunch of things I've uploaded and I've done over the past week and a half, and I've spent around 30 hours into this kind of section. There are many scripts here, but the main script you want to run and look at is new main.py and output. So this output is the output of my program. And I'll go into what all of this means and is right now before I even go into the program for the people writing the paper so they could start doing that. So in the descriptive statistics, you could get this so it shows more variables. But regardless, all the images are plotted in the program, and they're all in the classification and regression and EDA for the variables. So it gives you the descriptive statistics per column. It gives you the missing values, which there are none. It will give you the top features or most important variables, the importance of it for each classification method or regression. You can see in linear regression, the importance is all 1.5, right? So what do we have to do here, right? So I then give you the R squared error. I give you the expected profits, the best overall model by score. I give you all of that, and then also in the I give you not just the classifiers, but the ROC to the graphs as well. So basically, going through my program, what does my program do? So to use my program, you have to install Python. To install Python 3 or above, very easy, Windows or Mac install, or Linux. You will then have to install pip, which is usually included in the Python install. If not, it's a package manager, and you will have to install these package managers right here. And then to go through the file progression, if you're editing this, right? So I'm going to do this, and first thing, would you like to show the EDA, which is just the EDA graphs, which I won't. But once I'll do that, it'll give me the importance of all this stuff. It'll be training. And then it'll give me the graphs after. So if you want to mess around with how the graphs look, or if you want to mess around with the actual program, you absolutely can. So whilst that's running, it might take a little bit on your machine to run because this is, again, training models. So this is just a descriptive statistics portion. So first we go into data. So data equals pd.readExcel. That's why we have to use pandas. And when you see something like pd dot, that's just if you look up here in my program, I import certain things from this import as SNS, like matlab or matplot.lib.pilot as plt, right? So we exploring missing values in the data set, or before that, sorry, we rename the columns for better visualization. So owned is homeowner, kids is number of children, etc. And then selected columns, right? So this is this actual columns we're going to be working with. So, and then we print the missing values, which there are none, right? And then this EDA just plots out all of the variable relationships, which we have already done and are in these graphs. So you'll get a graph like this, for example. So now we're calculating the correlation matrix, and we're dropping ID, donor, and DMT. Donor and DMT being the two target variables, ID being the variable we're supposed to drop. It's just a numerical column. And and then we handle the missing values in the numerical columns, and handle fixing that ID column. And then we separate the target variables into Y classification, which is donor, which is a binary variable, and then regression with DMT, with a continuous integer variable. So identifying categorical columns. Select data type object category.column. So select data types again. This is coming from a library. So even though I come from a computer science background, I do not know all of these libraries. I've been working with them, but please look at the documentation for all of these functions, please. Because I've written a very, very good outline and only a couple tweaks are needed to be made. Then pre-processing with transformers, one hot encoder, and standard scaler. Just calling some functions with the numerical transformer and the categorical transformer, right? Categorical variables, numerical. We drop the ID again, just because there's some redundant code in here, but it's just good practice in such a huge Python script. So handling the actual missing values again, basically literally the same code but redundant. Preprocessor of the column transform. We then apply the transformation from the preprocessor, and then we split the data. So the train test split, right? Y classification, then Y regression, right? Random state, that's just that could really be any integer from 0 to 100, and the test size 0.2 since we're using 80% of the test size, right? Classification models, you could edit the parameters here, like neighbors, and we could possibly do something like add, or in the KNN classifier we could do something like just add more parameters basically, or add more like neighbor. As we see, which I might remove, and then again dropping ID again, just because of redundancy. And the linear regression, the parameters, there is none. So that's why all of the variables are going to have the same importance. So functions to feature or display feature importances, right? So this gives you these outputs for the certain classifiers. So what is the most important? Variables across the board for all the different classification methods after it's trained. So now this is the actual model fitting and tuning. Again, a lot of this code that I understand. So grid search equals this function, right? Which again I think comes from pandas. It takes in a bunch of parameters like the model info parameters, scoring accuracy, and then if it is the classifier in the model name, it does it's good, else it's R2. So if it's a classifier in model name, it does that, else it uses R squared as its metric. And then grid search.fit, if classifier in model name, else x train reg y target, right? So it's basically checking this classifier. And then the best model equals grid search.best estimator, since we're trying to, estimation has to do with precision. And then best models, model name equals model best model, and then score grid best score. And then that outputs the best model. And then gets feature names after pre-processing, and then display feature importance. Here's the actual evaluation of the models. This is basically all it's doing is accuracy. It's just the accuracy of the y test and then the y prediction. Precision score is y test over y prediction, right? And y prediction equals the prediction over x test. We go back to x test. Sorry, we don't send it in like that. We use that as a parameter here, but yeah, if we send in the x test and the y test model name, and then if the classification is true or not. And if it isn't, we use regression metrics. If it is, we use classification metrics. So for evaluating the models, this is again the y test. This is if it's classification, if it's not, and then you evaluate the model using this library function, and then just put in the parameters that you would see on the documentation or whatever IDE you have. Then finding the best models is not the most difficult thing in the world, since we already know all the scores of them. We're just iterating through them and getting the best one. Process the data, apply models, and export predictions. And this again goes into not nonprofit score yet, but it goes into model predictions for now, which I will fix. So summarize findings, just showing the best classification model, etc. And then here is the actual profit. Finding the best models, again, this is redundant. There's a lot of redundancy in this code. But so we have to basically find the profit per donor, which is the average donation minus the mailing costs. And then we find the rows in the data set, right? Because we're finding the true positives over the negative, or true negatives, etc. And we use precision for that. And then we calculate the profit basically off of that very simple thing. And then with this portion of code, this is the profit from regressions, but it still isn't implemented correctly. Again, if y'all can look at it, the people looking at my code, please edit that. So then we get the model precision, calculate the precision profit for classification models, doing it for the overall and regression models. This is again redundancy, but again my program is broke a couple times, so I like doing redundancy in this program just for safe measure. I also want to know y'all's opinion regarding if I should I don't think she really is expecting this, but so if we look at what she wants, your clients would also like to predict expected gift amounts from donors. So that's what that is. Or you could also, the grammar is really bad on it, actually. So your client would like predictions, or like predictions expected on gift amounts from donors. Or like to predict expected gift amounts from donors, or the overall profit from it. Kind of implementing this to predict expected gift amounts from donors. The thing is in the nonprofit score, it just has the donor as an empty kind of variable. I could just add in these two columns as donor and DAMT, basically. Yeah, thank you guys for watching. Please, I will be very, very, very thin this next week. I have other group projects I have to do, and I'm also doing stuff for IBM right now. So if y'all have any questions, please ask me. I won't be as involved as in the project, but I will do peer reviews, and I will be available for help if needed. So thank you guys. And if tomorrow, can you please find a plan, designate the writers, and yeah, thank you very much.